Good evening to Inche Hasley. I'm Kok Zhang from Group 3. Today, we would like to present on the hardware of mini aquaponics systems. My group consists of 6 members, who is Khairul Irfan, Satiswaran, Nur Fakira, Putri Najwa, Natalie Tan, and last but not least, it's me. Next, I would like to pass to Putri Najwa to present her parts.
This is our problem statement. Nowadays, aquaponics is a system that is commonly used in agriculture. There are many methods designed and aquaponic technology equipment was created. Present day, cultivating is required because water-based farming methods are recognized as not only sustainable but also produce crops that are safer to eat. In Malaysia, despite having many advantages over conventional and cultivation, the aquaponic method has not actually been widely implemented. This project is intended to address three major issues which are to monitor our system. Our approach is to design software for easy of monitoring system of instrument, device work and monitoring system for users. Second, to produce a new system without harming the environment, which is an eco-friendly system for ornamental fish and hydroponic plants. Third, to ensure this project is working automatically, which the nutrients are sent directly to the hydroponic root at any given time. The method of cultivation used and are susceptible to disease, less fertile and relatively difficult to implement in confined space. Large-scale agriculture production can further utilize the advantage of this agriculture strategy. Pesticide use will be reduced due to the controlled growing condition. The expected result will be this aquaponic system will stabilize ecosystem between plants and aquaculture animals. Project aim of this project is plants are cultivated in the grow bed while fish are kept in the fish tank in aquaponic. The ammonia contained water from the fish tank is fed to the grow bed, where billions of naturally occurring helpful bacteria break it down into nitrates and ultimate nitrates. Plants to aid their growth absorb nitrate and other nutrients. The plants clean and filter the water in the system in exchange. The water is subsequently recirculated back to the fish tank where the cycle begins again. There is our objective. First, to design software for easy of monitoring system of instrument, device work and monitoring system for user. Second, to develop a smart monitoring and control device for aquaponic, which is an eco-friendly system for ornamental fish and hydroponic plants. Third, to provide equality resources for aquaculture and hydroponic in a limited condition. There is our scope. First, the monitoring system software is controlled by using Arduino Mega microcontroller and digital sensor as a display for temperature and water level. Second, to build a space-efficient and affordable aquaponic system. Third, the multiple sensor is controlled by using Arduino Mega microcontroller, which is used in coordinate together to run the system smoothly.
Bismillahirrahmanirrahim. Jadi block diagram pula kita ada beberapa input di mana kita ada AC power supply, DC power supply 12 volt iaitu bateri. Kemudian ada sensor, range sensor sebagai water level, temperature sensor untuk baca bacaan suhu dan juga soil moisture sensor di mana membaca tahap kelembapan tanah. Kemudian kita ada output pula, sebagai output kita ada bulb 12 volt, AC water pump dan juga output LED sebagai indikator. Kita ada 4 LED, 2 merah dan 2 hijau. Last sekali kita ada LCD untuk bagi tahu user sebagai indikator. Jadi program bermula di mana Arduino Mega membaca bacaan suhu melalui sensor, temperature sensor di mana memberi bacaan, kemudian meletakkan bacaan di LCD. Jika bacaan suhu bawah 29, LED hijau akan menyala. Jika lebih 29 tetapi bawah 35, LED merah juga akan menyala secara berkelip 5 saat. Jika bacaan suhu lebih 35 degree Celsius, bacaan LED merah akan menyala secara berterusan. Kemudian range sensor pula, kita menggunakan range sensor sebagai bacaan isi padu air. Jika isi padu air berkurangan, relay akan bagi tahu kepada bulb untuk tidak menyala. Kemudian LED merah juga menyala. Jika tahap isi padu air mencukupi, relay akan terus kepada bulb akan menyala dan LED hijau akan menyala. Dan terus pada LCD juga, dia akan beritahu di mana bacaan air mencukupi. Seterusnya, soil moisture ini juga akan memberi isyarat kepada relay jika tanah lembab, relay akan beritahu kepada AC water pump untuk terus berjalan. Jika tanah kering, relay akan memberhentikan AC water pump. Sekian, terima kasih.
Here I'm going to explain on the circuit diagram. Our circuit diagram is drawn using proteus, and so the main component in this circuit is the Arduino Mega A2560 microcontroller. So from here overall we can see that we have 8 parts, which we have 3 types of sensor, 2 types of relay, 2 types of LED indicator, and then an LCD display. So the sensors we are using is the soil moisture sensor, raindrop sensor, and also the temperature sensor. And then we design 2 types of relay, which are lamp relay and another one is water pump relay. After that, we also have 2 types of indicator. So one is for temperature, another one is for water level. Then lastly, we will have the 16x2 LCD display. So basically, how the relays will be functioning. The first lamp relay, it will be triggered when the raindrop sensor detects that the water level in the aquarium is enough. So the lamp relay will be turned on, the lamp will be turned on, and then the green LED D6 will be turned on. After that, the LCD will print the water level okay. So inversely, if the raindrop sensor detects that the water level is not enough, so the lamp relay will be turned off, and then the indicator of red LED D7 will be turned on. After that, the LCD will print water level low to warn the user that the current water level condition in the aquarium is low. Okay, so the water pump relay will be triggered when the soil moisture sensor detects that the soil in the plantation is dry. So when the water pump relay is triggered, it will turn on the water pump to pump the water from the aquarium into the plantation. So inversely, when the soil moisture sensor detects that the soil is wet in the plantation, so it will turn off the water pump relay and then turn off the water pump to stop pumping water from aquarium into the plantation. Okay, so lastly, I would like to introduce the indicator from the temperature. So basically, there are 3 conditions for the temperature sensor. The first condition is if the temperature in the aquarium is less than or equal to 28 degrees Celsius, then the green LED D1 will be turned on. After that, the LCD will will print the current temperature value. And then the second condition for the temperature is if the temperature is in between 29 degrees Celsius to 34 degrees Celsius, then the D2 red LED will blinking, and then the LCD will print the value of that temperature value. And then for the last condition is if the temperature is higher than 35 degrees Celsius, then the D2 red LED will be turned on, and then the LCD will print the detected temperature value on the LCD screen. So that's all our design and how our component will be functioning in the circuit diagram.
As a summary, Mini Aquaponics system is a system which integrates aquaculture and hydroponics into one production systems. With the idea of aquaculture and hydroponics, we had added some of our ideas, which is using microcontroller Arduino Mega to control the systems. We have 3 inputs in this system, which is water temperature sensor, raindrop sensor, and soil moisture sensor. There's 4 LEDs for alert, 1 relay, 1 LCD to display, and a AC motor water pump. Next, I would like to pass to my partner Noh Fakira to explain the system flows.
Okey, jadi untuk program ni akan berjalan mengikut bacaan input dan tahap akhir. Kemudian pam air akan sentiasa hidup. Okay. Rain sensor kami gunakan untuk mengira tahap air. Bila tahap air mencukupi, indikator water level LED hijau akan menyala, kemudian lampu juga menyala. Okey. Jika tahap air berkurangan, indikator water level LED merah akan menyala, kemudian lampu akan terpadam. Okey, seterusnya untuk suhu kami akan menggunakan waterproof temperature sensor. Apabila suhu bawah 28 degree Celsius, LED hijau di indikator temperature akan menyala kerana sambungan relay di mana relay berfungsi sebagai switch. Jika suhu lebih 29 degree Celsius, LED merah akan berkelip. Okey, akhir sekali, jika suhu air melebihi 35 degree Celsius, LED merah di indikator menyala terus tanpa berkedip. Okey, akhir sekali pam akan mula air ke atas untuk proses menyiram tumbuhan.
Hello, we are here to present about the problem that we face during the project we do. The first problem is we use the AC pump to pump the water, so we cannot simply on the pump with the current. So we use the relay as a switch to on the pump. The second one is the soldering of our project. We use the soldering so it will be easily detached. So we solder it and we tape it with the electrical tape, so the wiring will be not easily detached. Then the third will be the water that comes through here from the tunnel here. So if the water will be pressure, the water will be splashed out from the aquarium, so the place will be wet. So we create a cover with the sheet, so it will be block the water that splash out from the aquarium. Thank you.
Okay, so I'm here to explain the safety use of our project. So first of all, the first matters with concern is the wiring. So the wiring, we use the electrical tape to tape between a wire to prevent the electric shock in the circuit, so that the short circuit will be avoided when the system is running. And the second concern we think about is the placement of the control box. So the placement of the control box we will put away from the aquariums, because our system are contained with the water elements, and it will splash out some waters and cause the control box get in touch with the waters, so the control box will be avoided with the waters.
Hello. For the future improvement of our project, so first thing we going to be do is to make a more reliable frame for this aquarium and our aquaponic system, so it can be carry more bigger plantation box and bigger aquarium, so it can be the more bigger process for the plantation. Then second, we want to reduce our circuit box, so it can be look more smaller and compact, so it will be easy to carry and easy to use. Thank you.
Okay, so our team is very confident that this system can be sold in the market because it's a mini aquaponics system, means that it can be implemented at any place, either indoor or outdoor. So the second point is this system is actually user-friendly system. It's suitable for those people that begin as a beginner for a gardener, so that they can no need to take care on their plants and also the hydroponic fish and something else. Yes. Thank you. Okay, so as a conclusion, our teams are successful to build and run these systems. So this system is eco-friendly and user-friendly because we use recycled material to build these systems, and it's also a user-friendly system because it is easy to use and suitable for beginner as a gardener people. So that's all for our presentation. Thank you.